Okay, so first thing we need to be able to do is talk about a triangle using the right words and having all the right terminology. So I'm going to draw myself a triangle, looks like this. First off, trigonometry applies to like loads of triangles, but we are only going to be talking about right angled triangles. So before we get too carried away, let's make sure we know that it's a right angled triangle. Hey Rose, come on in. All right, there's a couple of things we need to know. First off, we can identify which one is the right angle. So we know that's 90 degrees. Thank you. The only other thing we must know is that we need to know the size of at least one of the other angles. So this one over here, for example, let's say for argument's sake, we're told that this is 40 degrees here. It looks like it's a little bit less than 45, so 40 is probably a reasonable guess at this point. Whenever we're talking about an angle in trigonometry, there's a symbol that we use. It's called theta, which is kind of like an O with a loop through it. It's part of the Greek alphabet, so instead of calling it the angle, we'll usually just say theta. So in this case, theta is our 40 degrees. So I'm going to change colours here. I'm going to put theta. So my theta is referring to that 40 degree angle that's in this corner. Okay, we know that a triangle has three sides, and the first thing we need to be able to do is give them the correct names so that we're referring to the right parts. Now, first off, this one, the long one that's opposite the 90 degree corner, has a name. We're using it yesterday. It starts with an H. Hypotenuse, cool. So we're going to slap an H right there. That's the hypotenuse. Now, we've still got two other sides of the triangle that we need to name. Do you remember how to do this from year 9 and 10 maybe? It's a bit misleading. Like if we were talking about area, we'd be looking for a base. Now in trigonometry terms, what we're interested in now is one of these sides we're going to call opposite and one of them we're going to call adjacent. Now every time we use those words, it's always relative to wherever theta is. So we need to go back to looking at where theta is. Here it is over here. Now if I go from theta straight through the middle of the triangle, I end up over here. This is opposite. So slap an O on there. That's not 0, it's O for opposite. And that leaves just one more thing, A for adjacent. You remember? It's coming back to you? Cool. All right, so let's say we have another one over here, and I'm going to give you this angle here. We'll call this 62 degrees. If you can slap a little triangle on your page that looks roughly like that, can you go ahead and label theta, opposite, adjacent, and hypotenuse for me? Theta's the easy one. I put that right there next to the 62. That's my theta. It's not a very neat theta, but there it is.
Wait, what does theta mean?
The angle. It's like a nickname for the angle. Okay. Yeah. I always find that opposite and adjacent, it's easy to get them mixed up. So let's talk about the hypotenuse first, because that's easy. That's opposite the right angle. From theta through the middle of the triangle, here we go over here. Which one's that? Yep, that's opposite. And that leaves adjacent over here. All right, is this coming back to some of you? Who reckons they've never seen it before? Yeah, okay, cool. Who's got a vague memory of it? Yeah. Okay, cool. All right, now there's three little formulas that we need to know about this. I'm going to write them down for you. It looks like this. So the first one is sine theta. It looks like sin, but we pronounce it sine. Sine theta equals opposite over adjacent. Oh yeah. That's the first one. The second one, cos, cos, theta equals adjacent over hypotenuse. Does anyone know the third one? It is tan. Tan theta equals anyone remember? What combination of O and A have we not used yet? OA and H, I should say. It's O. Oh, hang on. I need to fix that. This is what happens when I get distracted. Just going back to my eraser, you might need to do the same. That there, sine theta is O over H. Sorry about that. No. There. Sine theta is O over H. Cos theta is A over H, and tan theta is O over A. Now, these words, sin, cos, tan, where have you seen them before? Yeah, they're sitting right there on your calculator, but you may not have used them much before. So they are, the thing is, sine, cos, and tan, they're not numbers. They're not numbers of themselves. They only work if you use them in conjunction with a number that is an angle that you've been given, which is why we're putting it with theta. So it's not a number, it's a relationship, okay? And it just so happens that the sine of an angle is exactly equal to that triangle's opposite side divided by its hypotenuse. It always works this way. It's important that you remember, sine, cos, tan, they are not numbers. They are relationships that we can use. So we're going to, you can remember these three formulas. This is something that you would have seen before at some stage, I'm sure. SOHCAHTOA. Don't remember it? No? Okay. Cool. Well, look, I think this is going to take, we're going to have to spend longer on this than we did on Pythagoras, but that's cool. We've got a bit of time. Just remember, sine goes with O and H. Cos goes with A and H. Tan goes with O and A. SOHCAHTOA. All right, next. Let's do an example. Here's one I prepared earlier. Look at that. Okay, I managed to draw a neat triangle, but I didn't manage to do any neat writing on it. Sorry, I'm working on it. First thing we always have to do here is identify the four important parts that we need. We must work out where theta is, where opposite, hypotenuse, and adjacent are, and we need to put those labels onto our triangle. So, where's theta? Yeah, that's where the 30 is, so that can go right there, which means, where is the opposite? Yeah, it's where the x is. So let's put an O over here. We know that this one over here is the hypotenuse because it's opposite the right angle, and that only leaves us with adjacent over here. So what we've got, I'm going to change to red here, we've got theta, we've got a hypotenuse. We don't actually know what the opposite is, but that is what we're trying to find. The only one we don't really care about is the adjacent. So what I want to know is, of the three things that we just talked about in SOHCAHTOA, which one actually uses theta, opposite, and hypotenuse? Yeah, it's sine, right? So we already know, by doing that step, we know that we're going to use sine. So the first thing we do is write sine theta equals opposite divided by hypotenuse. Just like with Pythagoras, always start with the equation that you've got. Now we're going to go back and we're going to put in everything we actually know. So sine 30 equals, what's the opposite this time? X. Good. So that goes up there, and the hypotenuse is 12. We're actually almost there. The catch is X is what we want to find, but currently X is being divided by 12. Remembering everything you know about solving equations, how do we get X by itself? We want to undo this divide by 12 thing, so what do? Times it by 12. In fact, and we're going to times this side here by 12. And because we're doing it to the right-hand side, we have to do the same to the left-hand side. Those cancel out. So what we're left with now is a little equation that says 12 times by sine 30 equals X. And it's at this point you pick up your calculator. And that's what you tap in. 12 times sine 30 equals... What is it? No. 12 times, you must do sine 30. 12 times 30 would be 360, but sine 30 will be something quite different. Yeah, it is 6. Yeah. All right, so what we know is 12 lots of sine 30, that's 6, equals X. So we've just solved for this triangle here that has a 30-degree angle in the side. We've just worked out that X is 6 units long.
Wait, but why is it sine? Like, why can't we use cos and tan?
We have to use sine because the information that we're giving our calculator is about theta, opposite, and hypotenuse. And if you look at the SOHCAHTOA thing you wrote down, the only one that uses theta, opposite, and hypotenuse is sine. Okay. Oh, and H belongs with sine
So
just
sine
there.
adjacent we use the cos.
Yeah, exactly. Yeah. All right. Working for you?
Okay.
Should we do it again? Rhetorical question. We need to do it again. This stuff takes time. Next one. Here's another one. Slightly less neat triangle because I couldn't find the tool that I used a moment ago to draw a triangle. So this is what we've got. Again, you need to label for me theta, O, H, A. Theta's easy to find. There it is there. H is easy to find. He's over here. Opposite is over here. A is over here. But, so we know we've got theta. We've got a hypotenuse. We don't know the adjacent, but that is what we're trying to find. The only one we don't care about is the opposite. So have a look back at your SOHCAHTOA. Cos, that's right, because cos theta is the one that uses A and H. So we write down our equation. Cos theta equals A over H. Next, put in everything that you know. Cos 40 this time. The angle is 40, so we put that number there. What is A? X, good. So X goes here. And H is 17, so that goes here. Very similar to the last one. We want to find X, but X is currently being divided by 17. How do you undo divide by 17? Times by 17. We're going to do that. Times 17 over here. We're going to do 17 times over here. That cancels out that. So now you go tappy tap tap on your calculator. 17 times cos 40 equals... I haven't done this advanced, I don't know the answer.
13.5.
13.03 is what I'm hearing. Now, you've had to round that, haven't you?
No, I just said that.
Yeah, so that you do have a screen full of decimal places. So we're going to say x is 13.03. We don't know what measure of, like, what units that is, so we're just going to say units. And that has been rounded to 2 decimal places. Oh, when rounded? Okay. Agree? Serves me right for not having my calculator next to me.
Is that recording on minutes?
On this page, yes. I hope that's how it's working.
Yeah, I was
But hey, if the people at home miss out, that's unlucky, but we'll deal with it. All right, last one. Number 4. Here we go. We got a 55-degree angle in there. It's still a right angle, so we can go ahead with this. Need to label theta, O, H, and A. So go ahead and do that for me. So what you should have is, we've got theta over here, we've got an adjacent over here. We want to find out what this opposite is over here. We just don't care about the hypotenuse this time. So which of our trig ratios, sine, cos, and tan, uses O and A, and tan? Yep. And that one looks like tan theta equals O over A.
Wait, yeah.
Put in all the information we have. Remembering we want to get x all by itself, so we're going to times this side by 23. We're also going to times this side by 23. That one cancels out that one. And then you just need to do some tapping on your calculator. So what was that? 17.14 equals x. So x equals 17.14 units 2 dp. Yep.
Yeah, I got 32.
That's okay. I was actually hoping that this would happen because I reckon I've got a theory on this.
How do I do it right though? Like, 23, 10, right?
Did you put a time sign in?
Yeah,
Did you by any chance do tan 55 times 23?
maybe. Wait, 23. Oh, that's what
I still have the same answer.
Okay, some calculators, if you do 23 times tan 55, it should give you the right answer. I'll come back to that in a minute.
So I just did 23, 10 times. I didn't know anything, but it wasn't that.
Okay.
Is your calculator set on something other than degree?
That was the other thing I was going to suggest. You need to make sure your scientific calculator is always set in degrees mode. You've got degrees, radians, and gradians. So if you can see somewhere on your screen where it says deg, that means you're in the right mode. If you can see rad or grad, it's going to give you the wrong answers every time you do trigonometry. So something to watch out for.
So,
Yep. Still getting it wrong.
Might be sick.
23
32.85.
times 3, 10, 55. Yeah, so I get 32.85.
Yeah.
So x equals 32.85 units, and that's accurate to 2 decimal places. So just double check that your calculator is in degrees mode.